All right, hey guys, today we are going to do lesson 10.5, which is the probability of compound events. By the end of today, you're going to be able to make an organized list, table, or tree diagram to find sample spaces and the probability of a compound event. So by the end of this video, hopefully you can tell me what a list, table, and tree diagram are, and what a compound event is. So if you guys can open your math book up to page 547, we will get started there. All right, so on page 547, the first thing we are going to talk about is what is a compound event. So a compound event basically consists of two or more simple events. A simple event would just be like flipping a coin. It's just doing one thing, rolling a dice. Those are simple events. So now a compound event consists of if you do two things. So maybe you roll a dice and then you flip a coin. That's a compound event. So we are going to start by trying to find the sample space of a compound event. To do that, the first thing you need to do is figure out, like, hey, what could I get when I roll a dice? Well, I could get a 1, 2, 3, 4, 5, or 6. So you start with listing that out. What could I get when I flip a coin? I could get a heads or a tails. That's kind of your first step when listing the sample space for a compound event. So now if we want to know, like, what is everything possible that you could get, you could actually use something called an organized list or a table to keep track of it. So we'll show you a couple different ways you can do this. So here would be, this would be kind of like an organized list. So if you roll the dice first, you could get a 1, 2, 3, 4, 5, and 6. But then after you roll the dice, and let's say you got a 1, you could get a 1 and a heads, or you could get a 1 and a tails. So here's where I recorded the results. I could get a 1 and a heads or a 1 and a tails. Or I could get a 2 and a heads or a 2 and a tails. So 2 heads, 2 tails. Or I could get a 3 and a heads or a 3 and a tails. You see how I'm listing those out? A 4 and a heads, a 4 and a tails. So you can, this is one way to list all the different outcomes. Some people like to list it like this, like, hey, I could get a 1 and a heads or a 1 and a tails. I could get a 2 and a heads, a 2 and a tails, a 3 and a heads, 3 and a tails. You can kind of keep going, 4 and a heads and tails, 5 and a heads and 5 and a tails, 6 and a heads, 6 and a tails. So if I look at this, there are, I'm going to count how many different possible things I could get. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 possible outcomes in the sample space for this compound event. And it's compound because I did two things. I rolled a dice and then I flipped a coin. All right, there is also something called a tree diagram that you can make to organize all the possible outcomes, because we're going to get to even some more complex ones where there's even more things that could happen. So if I flip a coin, this is called a tree diagram. I could get a heads or I could get a tails. Now I draw some branches going off of that. That's why it's called a tree diagram. I could get a heads and a 1, a heads and a 2, a 3, 4, 5, 6. Okay, same thing down here, tails and a 1, tails and a 2. And then all you do is you kind of go across and you write the outcome. So on the top here, I'd be like heads and, I'm not going to write the whole word. You guys can always abbreviate, by the way, too, when you're making these, just to save space. I could get a heads and a 3, a heads and a 4, heads and a 5, or a heads and a 6. Same thing down here. They already listed tails and 1, tails and 2, tails and 3, tails 4, tails 5, tails 6. Now to find the total possible outcome, a little trick is you just kind of count down here. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can also get that number from right there as well. So this is a tree diagram, which you can use to organize your information. So let's look at page 490 or 549. We're going to find the sample space of a compound event. So let's say I suppose a penny and a nickel are tossed. What's the sample space of possible outcomes? Well, I think about first, well, what could I get? When I toss the penny, I could get a heads or a tails. And when I toss the nickel, I could get a heads or a tails. So if I made a little diagram of this, here's one way you could show it. Okay, so if I start with the penny, I could get a heads on the penny, and then I could either get a heads or a tails on the nickel. Or if I got a tails first on the penny, then I could either get a heads or a tails on the nickel. My results would be, if we just kind of go straight across, I could get heads and heads. That's why they have that there. I could get heads and then tails. So I'm just going to list that out, heads and then tails. I could get, I'll use a different color. I could get tails and heads. They listed that there. Or I'll use pink on my last one. I could get tails and tails, which I would list here. So there are 4 possible outcomes that I could get. All right, now I want you guys to kind of think about this. So when I flipped a penny, there was 2 outcomes. And a nickel, there was 2 outcomes. And total, I got 4. Now, if you think about the last one that we did when we rolled a dice, there were 6 outcomes for when I rolled a dice, 1 through 6. And then I flipped a coin, there was 2, and I got 12 total. Do you notice any relationship how I can get from here to here? All right, quick, easy way is if you figure out for each simple event how many outcomes there are, there's 2 and 2. 2 times 2 is 4. There will be 4 possible outcomes. Same thing here. When I roll a dice, there was 6 options I could get. Flip a coin, there was 2. 6 times 2 is 12. That's a quick way to get the total possible outcomes. So I could also do that same problem using a tree diagram. So when I start with the penny, I could get a heads or a tails, and then I could get a heads and a tails on the nickel. So again, you can just kind of list this out. Here would be tails, heads. Here would be tails, tails, if you just kind of follow the branch. And again, there's 1, 2, 3, 4 possible outcomes. So when I do my flipping, I could get a heads and a heads and a tails and a heads, or a tails and a tails. All right, so on page 549, I'm gonna have you try the check. Now, there's not a ton of space down there, so you're gonna wanna use all the space like over on the side of page 549, all those lines that are over on the side, to either try to make a list or a tree diagram. I'm gonna end up making both with you, but I want you to try one or the other. Or try both if you want. All right, so your math teacher owns 3 pairs of pants and 3 pairs of shoes. There's gray pants, green pants, and blue pants. And then black, brown, and tan shoes. So let's start with if they choose a pair of pants first. So they can either choose, I'm gonna do a tree diagram going up and down. They can choose gray pants, they can choose green pants, or they can choose blue pants. Okay, now I'm gonna draw my tree diagram going down just so you guys can see what it could look like. After his pants, he has 3 options for shoes. He can do black shoes, he can do brown shoes, or tan. I'm just abbreviating. Same thing for green. He can do black, brown, or tan. And then with his blue pants, he can wear black, brown, or tan. So total, you guys can see if you just count this bottom row, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 total options. It says if he randomly chooses 1 pair of pants and 1 pair of shoes, what's all the sample space? So there we have them all. You could list them all. You could say, oh, so gray and black, gray and brown, gray and tan, green and black, green and brown, green and tan. Same thing with the blues, and that would be your sample space. All right, so for the next one, let's go ahead and see. A pizza shop sells pizzas. You can get pan or thin crust. You can get red or white sauce, and you can get pepperoni, mushroom, or plain cheese. So if I want to know how many possible outcomes that is, I can just kind of think, hey, for the crust, there's 2. For the sauce, there's 2 choices. And for the toppings, there's 3. So I can do 2 times 2 times 3 to get me the outcomes. Well, 2 times 2 is 4. 4 times 3 is 12. There are 12 possible outcomes. Now, if I try to fill in the table, you guys can probably see how this works. I'm not going to fill in the whole thing, but we can clearly see how this works. He can get a pan or red, and then he could get pepperoni, or pan, red, and mushroom, pan, red, and cheese. That would be my choices. So I could say, hey, pan, red, and mushroom, pan, red, and cheese. Same thing, he could go pan and then white, and then he could get pepperoni, mushroom, or cheese. So it'd be pan, white, pepperoni, pan, white, mushroom. So pan, white, mushroom, or pan, white, cheese. And then we do the same exact thing for thin crust. He could do thin and red, and then he can get pepperoni, mushroom, or cheese. Or he could do thin and white and get pepperoni, mushroom, and cheese. Either way, you can see all 12 of the choices down there. Now I'm going to do that same thing with a tree diagram down below. Now again, you can draw a tree diagram going sideways or up and down. So always start with your first thing. You can do pan or thin. Okay, so I'm going to say I can do pan or thin. And I leave some space so I can write. Then I'm going to go to my sauce. There's 2 options for sauce, so I draw 2 branches. He can get red or white sauce. Same thing for thin, 2 options, so red or white. And then finally, after that, now my next choice has 3 choices for the toppings. So I draw 3 branches, pepperoni, mushroom, cheese. Same thing off of here, pepperoni, mushroom, cheese. Pepperoni, mushroom, cheese. Pepperoni, mushroom, cheese. So I just drew a tree diagram. Now if I want to follow it, I kind of go like this. Pan, red, pepperoni. Pan, red, mushroom. Pan, red, cheese. Pan, white, pepperoni. So you guys can kind of see me following the tree to see all the different options. Total there are 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, why don't you guys try the check on the next page, page 551. Pause the video and try it yourself, and then I will go through it. All right, so I have 3 types of bread. I'm going to draw going up and down tree diagram. I could get white bread, wheat bread, or rye bread on my sandwich. And then after that, I have some different choices for the meat. I can get turkey, ham, roast beef, or chicken. So there's got to be 4 branches going off each of these. This tree diagram is going to get a little crazy. I can get turkey, ham, roast beef, or chicken. Turkey, ham, roast beef, or chicken. Same thing, roast beef or chicken. Now after that, I can choose my cheese. I can get cheddar or Swiss cheese. So now off of each of the meats, I have to do my cheese. I can get normal cheese or Swiss. Normal cheese or Swiss. You see how I'm drawing 2 off of each, cheese or Swiss. Same thing here. The different types of cheese I have to draw for each of them. You guys are gonna see this is a lot of outcomes. Okay, so total, if I count all of those at the bottom, I see 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So there are 24 possible outcomes for my sandwich. Now, I could have also got that, remember, by saying, hey, for the bread, there are, oh my gosh, and I even missed, I did white wheat, rye. There's also sourdough. So there's actually more. I should have done sourdough as well. And then the 4 branches, and then 2 off of those. So there's actually even more choices. There's 2, 4, 6, 8 for the wheat, 8 for the white, 8 for the wheat, 8 for the rye. So there'd be 8 for the sourdough. So there's actually 32 choices. I could have gotten that by also saying, hey, for bread, there's 4 options. For meat, there's 4 options. And for cheese, there's 2 options. So I could have done 4 times 4 times 2. Which ends up being 32. So there are 32 different outcomes in that sample space. You could have made this as a list as well, but this was just the tree diagram version. All right, let's go to page 557 and let's try one now. This is what you're gonna see kind of in the class kick, so I wanna make sure you feel pretty good at doing these. So I have an Italian ice shop selling ice in 4 flavors, lime, cherry, blueberry, and watermelon. And then I also can get a plain mixed with ice cream or as a drink. I want to make an organized list or table for the sample space. So instead of a tree diagram, let's try a table. All right, so I kind of think if I'm doing a table, there's only 2 options. It's kind of nice to do a table then. It's like a multiplication chart. I could get lime, cherry, blueberry, and watermelon. Or I could get, and then I could get plain ice cream or a drink. Okay, so if you kind of think of it like a multiplication chart, this is really nice with 2 options. You could say, hey, I could get lime and plain. You sort of fill it in like a multiplication chart. Or I could get lime and ice, or lime and a drink. Or I could get cherry and plain, cherry and ice, cherry and drink. Or I could get blueberry and plain, blueberry and ice, blueberry and drink. Or watermelon and plain, watermelon and ice, or watermelon and drink. So I just made a list. Now, some people might like just doing it like this and list it out like this, lime and plain. You could list it like that, lime and ice, lime and drink. So you could kind of go like that too. And then you could go to cherry and do the same thing 3 times. Okay, and then you could go to blueberry and do the same thing 3 times. And then you could also do watermelon, and you'll still come up with the same amount of options. And you guys could have figured that out to start with, but there's 4 different flavors and then 3 different options. So there should be 12 total. If we look at our table, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 different possible outcomes I can get when I go order my ice cream. All right, so our learning goals for today's lesson was, first of all, can you tell me what a compound event is? So hopefully you can do that. Second of all, can you find the number of possible outcomes? So you can either do the table or tree diagram and then you can count them, or you can use the little trick I showed you. And then lastly, can you actually list the sample space of a compound event? So can you either make a list, a table, or a tree diagram to show all the possible outcomes of an event? Now you guys are going to practice in a class kick. If you need help, please check in with your teacher.